In this video, we'll show you how to configure a pair of Aruba AP-577s for a point-to-point bridge connection using Aruba Central running firmware versions 8.11 and 10.4. At the end of the video, we'll test the link performance over various distances using a variety of channel settings. Make sure both of your APs are in the default factory state and connect them both to the same network with access to the internet. We'll start onboarding the APs to Aruba Central. Log on to the HPE GreenLake portal, then onboard the APs using their serial number and MAC address. Assign Aruba Central applications to the APs and apply subscriptions. Then go to Applications and launch the Aruba Central application. Once you're in Aruba Central, click Organization, then Group. Add a group and give it a name. The group will contain access points and, depending on the preferred architecture, select Aruba OS 8 or Aruba OS 10. We will cover the config detail that'll work for both Aruba OS 8 and Aruba OS 10. Move the APs to the newly created group. We are now ready to configure the APs. First, let's create a wireless network on the 2.4 gig radio for management access. This is not part of the point-to-point setup. Instead, it's simply for the purposes of this demonstration video, as it allows us to check AP status and initiate throughput tests when we're out in the field. Go into the newly created group, then Devices, and click on the Config button at the top right-hand corner. Click on Show Advanced to expand the full menu. Under the WLANs tab, click on the plus sign to add a new network. Give it a name and unselect 5 GHz, making this SSID 2.4 GHz band only. This means that this SSID will only broadcast of the 2.4 gig radio and will not interfere with our point-to-point link performance, which will use the 5 gig radio. Leave the IP and VLAN assignments at defaults. Set the passphrase and make sure there are no access rules set on this SSID. We'll now begin the point-to-point configuration. First, let's set up the SSID that will be used for our point-to-point link. Under the WLANs tab, click on the plus sign to add a new network. Give it a name. Unselect 2.4 GHz, making this SSID 5 GHz band only. Click on Next. Leave the IP and VLAN assignment at External DHCP Server and Native VLAN respectively. Set the passphrase, and ensure access rules are set to Unrestricted before finishing the config. Under Access Points, select and edit the AP that will be set up as the Mesh Portal. The Mesh Portal is your upstream AP, whereas the Mesh Point will be the downstream AP that you want to extend your network to. Give the Mesh Portal a name and set a static IP. Under the Radio tab, you can choose to set static channel and desired power settings. Make sure you select Outdoor as the installation type. This will limit the channel and power settings to comply with your regulatory domain for outdoor use. Click on Save Settings. Now, it's time to configure the Mesh Point AP. Give it a name and set a static IP. Change installation type to Outdoor and save. Now, we are going to make some cluster-wide changes. Under the System tab, set the country code and make sure Extended SSID is disabled. This needs to be disabled in order for meshing to work. Click on Save Settings. We'll reboot the APs once all configurations are completed. Move on to the Radios tab and expand Access Point Control. This is where you can control your channel width. By default, it's set to 80 MHz on a 5 gig radio and 20 MHz on a 2.4 gig radio. If you want to go down to 40 MHz, turn off the 80 MHz toggle. If you want to go down to 20 MHz, uncheck the Wide Channel Bands option. But for the time being, we'll keep the defaults, as we'll manually set the channel width later when we're testing. Now we need to configure the wired part of the mesh link. Navigate to the Interfaces tab. Select and edit Default Wired Profile. In our case, the profile is applied to the wired port used to connect to the wired network interface 0. Expand Advanced Settings, ensure PoE is on, and Admin Status is set to Up. Then go to the VLANs tab. I want to be able to stretch all of my VLANs across this bridge link, so I need to configure the wired port as a trunk. Native VLAN set to 1, and all VLANs allowed. You need to make sure that these settings match what's configured on both of your switch port uplinks. Under the Security tab, turn on Port Type Trusted, then make sure there's no access rules set under the Access tab. Click on Save Settings. Now it's time to reboot the APs so these settings can take effect. Click on the List menu to get out of the Config menu. Select all APs and click on the Reboot button. Once the reboot has been completed, you should see both access points are back online. If you click into the APs, you will see that both APs are running mesh portal mode under 5 gig radio. This is because they are both connected to our LAN and are using the Ethernet port as their network uplink. You should now disconnect the point AP from your LAN to physically move the AP and install it at the remote location. It'll take about 5 to 10 minutes to boot up and appear as online on the dashboard. Once the point AP establishes connection, you should see the mode has changed to mesh point. Let's finalize the configuration of our point AP. Going to the Config menu, under Access Points tab, edit the point AP. Go to Uplink subtab, change Uplink Management VLAN to 1 and Ethernet 0 interface mode to downlink. This is because our point AP should use the wireless link as the uplink, not the Ethernet port. Click on Save Settings and reboot the point AP. For AOS 10 configuration, under the group, go to Devices, then the config icon and click the System tab. Expand the mesh settings. To add a mesh, click the plus icon on the mesh table. Give it a name and key. Change mesh role to auto. This allows an AP to automatically detect the mesh role and configure as mesh portal or mesh point, and select 5 GHz as the mesh band. Click Save Settings. Finally, create a new wired port profile to set the Ethernet 0 port mode to downlink. Complete setting up the profile as required. It's time to performance test our setup, initially at 100 meters apart. We've attached each of the AP-577s we set up earlier to an Axeltex accelerator battery and a WLAN Pi running iPerf server. Before running our tests, we performed a quick check of the spectrum in the area using Ekahau Sidekick as well as WinFi scanner to identify any potential Wi-Fi and non-Wi-Fi interference. Based on this scan, we settled on channel 100, which had a few other wireless networks present but wasn't overly congested. If you're provisioning long-distance point-to-point wireless links, you need to understand the concept of a Fresnal zone. A Fresnal zone is a three-dimensional elliptical region between the transmitter and the receiver as shown on this diagram, and it's dependent on the distance and transmit frequency. You can find Fresnal zone calculators, such as this one shown via a quick Google search. You should aim to have at least 80% of your Fresnal zone free of obstacles for your link to operate at its optimum. Direct line of sight between the APs is always good to achieve, but keeping your Fresnal zone clear will ensure the highest possible performance. Since we have chosen channel 100 for testing, which runs on 5.5 GHz, and are transmitting over 300 meters, we can calculate that our Fresnal zone radius is just over 2 meters. In this instance, we kept our Fresnal zone clear by placing the APs on tripods and raising them 2.4 meters off the ground. Our testing procedure was to configure the link to use 20, 40 and 80 MHz channel widths and perform a throughput test at distances of 100, 200 and 300 meters respectively. This table shows the summary of our test results. We were pleased to see performance over 100 and 200 meters close to 560 megabit per second, and only experienced around 10% performance loss at a distance of 300 meters. Plus, there were minimal differences between running 80 MHz and 160 MHz. This proves that the AP-577 is very capable for point-to-point deployments over 100, 200 and even 300 meters. And there you have it. Thank you for watching.